Hi, 8th grade. So today our extension is exactly what we're doing in class. So the first problem says a conservative estimate of the number of stars in the universe is 6 times 10 to the 22nd power. The average human can see about 3,000 stars at night with his naked eye. How many times more stars are there in the world than the average compared to the stars a human could actually see? So this is the number of stars, and this is the stars humans can see. If it's asking us to find how many times bigger something is, what operation do we need to be doing? Yeah, we need to be doing division. When we divide, we put our bigger or smaller number on top. We're going to put our bigger number. Which one is our bigger number? This is actually really hard to tell looking at these two numbers right here. Well, actually, it's not that hard to tell. But still, we're going to convert this one into scientific notation first. So where does the decimal go in this number? Between the 3 and the 0. How many times did you have to move it to get there? Did it just get, so you have to move it 3 times. Did it get bigger or smaller when we move the decimal? Or is this a big number or a small number? It's a big number, so our exponent will be positive. So I have 3 times 10 to the 3rd power. Now, which one is bigger? I can look at my exponents. 22 is a lot bigger than 3. So my bigger number at the top, because I want to see how many times bigger this one is, so I need to divide into that one. And then I'll put my smaller number on the bottom. 3 times 10 cubed. All right, now when I am dividing scientific notation, what will I start with? Yeah, I'll start with 6 divided by 3. 6 divided by 3 is 2 times 10. What do I do with my tens here? Yeah, I'm going to subtract my exponents. Why? Because I am dividing. So 22 minus 3 equals 19. So it'll be 2 times 10 to the 19th power. All right. I'm also going to do the first problem on the independent practice. So it says the estimated world population in 2011 was 7 times 10 to the 9th power. Of the total population, 682 million of those people were left-handed. What percentage of the world population was left-handed according to this estimate? We're trying to find a percentage, and we have 7 times 10 to the 9th power and 682 million. All right, 682 million can be written how? I need to add 6 zeros behind this. And the first thing I'm going to do is convert this into scientific notation. Where does my decimal need to go? Right between the 6 and the 8. How many times did I need to move it to get there? 1, 2, 3, 4, 5, 6, 7, 8. So this will be 6 and 82 hundredths times 10 to the 8th power. Okay, now I'm trying to see what percent of the world population is left-handed. So percent, what's our equation for percent? Right, part over whole. So part over whole. Is my part the people who are left-handed or the total population? Now my part is going to be the people who are left-handed. So my part is 6 and 82 hundredths times 10 to the 8th. Here, my whole is 7 times 10 9th power. We are doing division, but it says approximately. What does approximately mean? Approximately means I need to estimate. So when I'm dividing these two numbers, what is 6 and 82 hundredths divided by 7 approximately? 6 and 82 hundredths is really close to 7, so this can be approximated or estimated as 7 over 7, which is just 1. Now what do I do to finish up? Yeah, I need to subtract my exponents. I'll get 10 to the negative first power. Okay, so now that I have 1 times 10 to the negative first power, I still need to convert this into a percent. So I'm going to convert this back into standard form. Is this going to be a bigger number or a smaller number when I multiply it by 10 to the negative first power? Yeah, it'll get smaller. Why? Because a negative exponent means a fraction, which means division. So I'm dividing by 10, which means I need to move my decimal this way. So this becomes 1/10. Now that I'm making it into a percent, what do? I multiply by 100. So I'll go 1, 2. When I multiply it by 100, I just move my decimal twice, and my answer will be 10%. Go ahead, pause the video, try number 2 on your own, and then we'll go over it together. All right, the first part is easy. You're just writing it in scientific notation. You'll put the decimal here. You needed to move it 4 times. So you'll get 3 times 10 to the 4th power. If it says single-digit integer times the power of 10, that's the same as scientific notation. Go ahead, try the second part. All right, for the second part, it is asking us to find the total number of breaths a human takes in their life. So this is breaths per day. So if they take this number of breaths per day and they live about 30,000 days, how many breaths will they take in their entire life? What operation do we need to do to figure this out? Yeah, I'll need to multiply. So I'll have 3 times 10 to the 4th times 30,000. In order to make multiplication easier, I want to convert my 30,000 into scientific notation, which I already did for the first part of the problem. So it's just 3 times 10 to the 4th times 3 times 10 to the 4th. I can start by multiplying my whole numbers. I'll get 9. Then I can multiply my tens. When I multiply my tens, what do? I add my exponents. So it'll be 9 times 10 to the 8th power as your final answer. The last problem on the back is a challenge problem. If you're in Princeton, you will get +5 for solving it. All right, good luck.